Okay, so we've talked about the protons, neutrons, and electrons. And now I'm going to talk about kind of like the history of the atom or the atomic model. And it started off with Democritus, and he came up with the term atomos. And that was the smallest part, for the most part, he called an atom or an atomos. And the kind of the weird thing is now when we look back on it, it's weird. But for him, anytime you took and cut something down to the smallest part, the smallest bit of it, you would have an atom of it. So you could have an atom of bread, or you could have an atom of wood, or you could have an atom of water. But he is the one that's credited with the term atom. Um, then Aristotle came up with the concept of earth, air, fire, and water. And all matter was made up of these four elements. And an example in his eyes, or an example that's given a lot, is the burning of wood. So wood is with it all mixed together. And as you burn it, you can see the fire. Smoke is given off, so that is air. And if you've ever watched a log or a piece of wood burn, sometimes there's a liquid that comes out of the end, depending upon how dry it is. But that's the water, and the ash that was left behind was the earth. So for Aristotle, everything was made up of different amounts of earth, air, fire, and water. And each group of people kind of had their own sets of this. So it wasn't an island. It wasn't necessarily just one person came up with it, but other people had very similar ideas. The Chinese, they added metal. And the Japanese, they had something that they called the mind. And that was the spiritual consciousness or your perception. And sometimes it's called the soul. And people have done experiments on trying to figure out if the soul has mass. But that earth, fire, air, those four are in a lot. And the Japanese also had space, or lack of anything, instead of metal as compared to the Chinese. But it all really kind of started in 1908 with John Dalton. And his first model is that an atom was something that was round, and solid and could not see it. And it was called the billiard ball model. And all matter is made up of elements, of different atoms. All matter is made up of atoms. And at this point in time, we started to have elements. We knew that there were things that could not be broken down smaller, that in chemical reactions, that these atoms were rearranged. And this is how we came up with the law of conservation of mass, or the law of conservation of matter, is that matter is neither created nor destroyed, it just changes forms. And this was a big step. Also during this time, chemistry wasn't necessarily a good thing. It was kind of like the dark days of science. This is also the alchemy time, where people were trying to find the elixir of life and turn things into gold. Then J.J. Thomson, he came up with the idea that there was a positively charged things in the atom. And he called it the plum pudding model, that in this atom, there were positive things that were in the atom, and there were negative things. And J.J. Thomson came up with discovering the electron and won the Nobel Prize on it. And now we have TVs that are like this thin, but back in the day, or some of you still might have, I still have a couple of them that are really deep. And inside there is a cathode ray tube. And that cathode ray tube shoots out electricity, and that electricity in essence is electrons, but it could be bent with a magnet. And that is kind of how the electron was discovered. And this is the same reason why you're not supposed to take and put magnets up to your TV screen, is because that magnet is going to pull that energy or pull those things to it. And then as soon as you pull that away, it's going to create a kind of a dead spot where that cathode ray can't hit, and you have a dark spot on your TV. Ernest Rutherford, he came up with the shocking idea that atoms are primarily made up of empty space. So this is an atom, and in here is the nucleus. Out here is where the electrons are, and he shot particles through that gold foil, and a lot of it went through, and some of it bounced back. Well, if you shoot something positive and it hits something that's positive, those are going to repel. So Ernest Rutherford came up with the idea that all of the protons are in the nucleus, and that's where most of the matter is, or most of the mass of an atom is. So in the nucleus, we have protons and neutrons, and that's where the mass of the atom is. Where these electrons are flowing around out here is pretty much empty space. And one way of taking a look at it is if you take a football stadium and you put like a marble or a pea at the 50-yard line, that's the nucleus. The electrons are filling up this area, and filling up isn't necessarily the best way of saying it because they're in a particular area, and they're called shells or orbitals. But all of this area up here is for the most part empty. There are a couple electrons moving around in there, but if there's an electron not taking up that space, then it's empty space. So it's kind of weird when you touch your desk or touch something. In essence, you're touching the electrons on that outermost shell. And then Chadwick took alpha particles and sent them through and found out that the mass of the atoms would change. And the mass of the atoms, by them changing mass but not changing identity, that meant that something else had to have been given off. And we know if we change protons, the element changes. But what Chadwick figured out is that in these atoms are neutrons. There's something that has mass and takes up space and can be lost. So Chadwick was the one who discovered neutrons. And this is kind of a recap. The nucleus of an atom contains protons and neutrons. Protons are positively charged, neutrons are negatively charged. The electrons in the atom are responsible for the chemical properties. So electrons kind of give an atom its characteristics. Protons make an atom what it is. Electrons tell us how it's going to act. And I say what makes an atom is protons, like what makes an apple pie is apples. What gives an atom its characteristics is electrons. What gives an apple pie its characteristics is going to be like cinnamon or sugar or crust or caramel or whipping cream or Cool Whip or something like that. The protons and the neutrons make up all of the mass, and we are saying all of the mass because the mass of an electron is like 1/1600th of a proton. So it would take 1,600 electrons to equal the mass of one proton, and no atom is that big. So protons, we give a value of 1, an atomic mass of 1. Neutrons get an atomic mass of 1, and electrons get an atomic mass of 0. So the identity of an atom is determined by the protons, and atoms, and we'll come back to this later, atoms of an element with different number of neutrons are called isotopes. And atoms can gain and lose neutrons, and they don't really change. Well, some of them become radioactive. And they can also gain or lose electrons. and we'll be talking about that in the future. And if this layout is a little bit different than the one that we've been working with, but boron is the name. 5 is the atomic number. That's the number of protons, or the number of electrons. B is the symbol. The symbol is always going to be, as long as it's been identified, is going to be 1 letter or 2. And the first one's always capitalized. The second one is always lowercase. And this is the atomic mass or the atomic weight. And that's an average. And the atomic mass or the atomic weight will never be a whole number because it's an average. Okay, have a great day.